Welcome back. Today we are going to look at section 3.1. We're starting to work on solving systems. We have several different methods for doing that. Today we're focusing on solving by graphing. When you have two or more related unknowns, you may be able to represent the relationship with a system of equations, which is a set of two or more equations. A solution of a system is a set of values for the variables that make all of the equations true. One method is to graph the equations and find the point of intersection. So notice that both of these equations are in slope-intercept form, so we should be able to graph them that way, starting at our y-intercept and then using our slope to get our line graphed. We're going to do these in two different colors so that we can keep straight which one is which. So my first one here I'm going to do in blue. We have y equals 3 halves x plus 4. So we're going to start at 4 on our y-axis, and we're going to do a slope of 3 halves. So up 3 over 2, up 3 over 2. And remember, we can go down 3 and back 2, and we're getting that same line. Down 3, back 2, down 3, back 2. All right. And then we're going to draw a line through that. So let's get our line here. All right. There we go. Okay, so there's our line for our first one. And then our second one we'll go ahead and do in green. This one we are starting at -4 on our y-axis. And this time we want a -1 slope. So down 1, right 2, down 1, right 2. Now I am trying to find where the lines intersect, so I'm going to stop moving in that direction and start going in the reverse direction. Up 1, back 2. Up 1, back 2, since I'm trying to find where those lines cross. Okay, so again, I'm going to draw a line in there. We'll make this one green. All right. Come on. All right, well, somehow it's not letting me grab that line. All right, there we go. Okay, so you will see that they are intersecting right here at that point. And we just need to find the coordinates of it. So it looks like we're going left 4 and down 2. So our solution would be -4, -2. All right, let's try one more. Again, the first one I will graph with blue. We are starting at a -2 for our y-intercept, and we are doing a positive 1/2 slope. So up 1 over 2, and down 1, back 2. Again, I'm trying to get as many dots because I really want this line to be accurate. And then we'll draw our line in. All right, our second one, we are starting at a 5 for our y-intercept, and we have a -3 for our slope, so we're going to go down 3, right 1, and down 3, right 1. So we're already seeing that point of intersection. All right, let's get a line in there. And so our lines are intersecting at this point right here. Coordinates of that would be 2, -1. Now, before we move on, I do want to have you try these points to make sure that they truly are the solutions. They have to work in both equations. So let's go back to our first one here. If -4, -2 truly is the solution to this system, it needs to work in both equations. So we're going to plug a -4 in for x and a -2 in for y, and we're going to check to see if it works. So we get -2 equals 3/2 times -4 plus 4. Well, 3/2 times -4 would be -12/2, which would be -6. If we add 4, we do get the -2 that we're supposed to get on the opposite side. Trying it in the bottom equation, again, putting -4 in for x, -2 in for y, we have -2 equals -1/2 times -4 minus 4. -1/2 times -4 is +2, minus the 4 gets us the -2 on the other side. So it does work in both equations, which means it is a solution. All right, let's try this one. Our solution we said was 2, -1. So again, I should be able to put a 2 in and get -1 for an answer in both equations. All right, 1/2 of 2 is 1. 1 minus this 2 gets us our -1. So it does work in the first one. Trying it in the second one, we have -1 equals -6 plus 5, and that is also true. So it is the correct solution. When graphing standard form equations, remember that we can change them to that slope-intercept form, or we can find the x and y intercepts, whichever we prefer. I'll show both ways on this first one. Let's go ahead and find the x and y intercepts. So I'm going to graph the first one in blue here. Finding x and y intercepts. Let's start by plugging a 0 in for y. That goes away, and we get -x equaling 1. Divide out the negative, we get x to be a -1. So we know that we're going to touch the x-axis at -1. Putting 0 in for our x-coordinate now. -1 times 0 is still 0, and we end up with y equaling 1. So we're going to cross the y-axis at +1. So you'll notice that those 2 points just have, it's aligned with a slope of 1. So we could continue to extend that line to get a more precise line drawn. Okay, let's go ahead and draw our line in. Okay. Our second one, we'll find our x and y intercepts again. If we plug a 0 in for y, 3 times 0 is 0, so this goes away. We have x being 15. And if we plug a 0 in for x, we get 3y equals 15, so y would be a 5. Now, for this one, we have a little bit of a problem because our y-intercept is fine at 5, but our x-intercept is at 15, which is beyond my graph. So here's an instance where it probably would have been better for us to go ahead and solve that for y. So let's work through that. If we take this green one, the bottom equation, x plus 3y equals 15, and solve for y, we would subtract our x. So 3y equals -x plus 15. And then we would divide everything by 3. So we get y equals -1/3 x plus 5. So we had the correct y-intercept. Our slope is -1/3, so we're going to go down 1 over 3, down 1 over 3. Again, we're going to draw that line in. Moving the wrong thing here. All right. And then looking for our point of intersection, we are crossing right here. Coordinates are 3, 4. All right, let's go back and check those. If we put a 3 in and a 4 for y, we get -3 plus 4 is 1, so that works. If we put a 3 in here for x and a 4 for y, we have 3 plus 12, which is 15. So it works in both. So we have found the correct solution. All right, for this next one, let's go ahead and use our table of values, finding our x and y intercepts, since our numbers here are pretty small. If we put a 0 in for y, we have -x equaling -2. When we divide out the -1, we get x being 2. Putting a 0 in for our x coordinate, we get y being -2. So we're going to cross the x-axis at +2 and the y-axis at -2. And we'll draw our line again. Should have arrows on both of these. Okay. All right, our second one. Let's go ahead and make a table for that as well. Putting a 0 in for y, we've got 2x equaling 4. So x would be 2. Putting a 0 in for x, we've got 0 plus y equals 4, so y is 4. So we're touching here at 2 on the x-axis and 4 on the y-axis. We'll draw our line in again. And we are intersecting here at the point 2, 0. So that is our solution. Again, we can check that in our equations. It does have to work in both of them. So if I put in a 2 and a 0, I get -2 plus 0 is -2. If I put a 2 in here and a 0, I get 4 plus 0, which is 4. So it is the correct solution. All right, now there are two special cases that don't have a normal intersection. We're going to look at those next. The first situation is parallel lines. They never touch, so if we're trying to find where two lines intersect, we aren't going to be able to find it if they're parallel. The second situation is what we call coinciding lines, and those are two lines that when you graph them, they actually land right on top of each other. And in that case, every point on the first line is also a point on the second line, so we have an infinite number of solutions. So let's try this first one. Notice they are both in slope-intercept form again. So I'm going to graph the first one, starting at 1 for my y-intercept, and using a slope of 2/3. So I'm going to go up 2 and over 3. Up 2 and over 3. Okay, and we'll draw our line in. Our second one, we are starting at -5. And we're going to do a slope of 2/3 again, so up 2 over 3. Up 2 over 3. And we'll draw the line for that one. All right. The board's off just enough that's making this hard. So if we look at our two lines here, we've got this one and this one. You'll notice that they are parallel, right? Same slopes. They are never going to cross. So we would say there's no solution to that system. All right, for our next one, these are in standard form. So again, I'm going to practice finding those intercepts. If we put 0 in for y, the 3y goes away. 2x equals 6, so x would have to be a 3. If we put a 0 in for x, that disappears. And we get 3y equaling 6, so y would have to be a 2. Let's plot that. We have the point 3, 0 and 0, 2. All right. Just doesn't want to hit in the right spot here. Okay. When we go to graph the next one, make our table of values. If we put a 0 in for y, we've got 4x equaling 12, so x is 3. If we put a 0 in for x, now we have 6y equals 12, so y is 2. And you'll notice that we're getting the same exact intercepts. So my green line would land right on top of that blue line. Every point on the green line would land on the blue line. We say we have an infinite number of solutions. All right, one other question here. It says you and your best friend have lemonade stands and decide to start a competition. You already have made $30 and you make about $5 per day. Your friend has $21 and makes about $8 a day. In how many days will you have the same amount, and what will the amount be? All right, so let's look at how we could write an equation for us. All right, so we have you and we have the friend. I'm going to run out of space here, so let's put it over here. All right, so for you, your total amount is starting with $30, and then we are gaining $5 every day. Okay, so that's my equation for me. My friend starts with $21, but is going to make more than me each day, $8 for every day. So in this case, y is the total that we're going to have, the total amount of money, and x is how many days it will take for us to end up with the same amount. All right, so we are going to, since our numbers are a little bigger here, notice our y-intercept is 30 for this one and 21 here. We're going to actually start our graph and put one of those little jagged breaks in there to show that we're not starting down at 0. And we're going to start with this being 21. We'd have 30 here. And 40 there. Okay, so we're starting with we're starting with $30. We'll graph us first. $30, so I'm going to have a y-intercept here at 30, and then I'm going to do a slope of 5. So I'm going to go up 5 and over 1. Okay, up 5 over 1, up 5 over 1. So that's an equation for how much money I'm going to have. I'm going to start at 30 and do a slope of 5. Okay, now my friend is going to start at 21, so down here at 21, but the friend has a slope of 8. So we're going to go up 8 and over 1. Up 8 over 1. up 8 over 1. And we'll draw that line in. So starting down here at 21 and doing a slope of 8. So that line is a little steeper, but you'll notice that we meet right here. And so our x's, remember, were number of days. On my x-axis, I'm over here at 3 for my x-coordinate. And on my y-axis, which is my dollars, I'm up here at 45. So that tells me that after 3 days, we will both have $45. All right, so your summary, you basically are just going to be graphing 2 separate lines and looking for where they intersect. Remember that you can always test that solution back in the 2 original equations and make sure that it works.